This is Maths with Victor, and we want to continue our works on SURDS. And today, we want to look at the product of binomial SURDS. Just like we can see, when we have a bracket and another bracket, it means we are multiplying the two expressions. We are multiplying the two expressions. How do we do that? Just like in algebra, when we are multiplying algebraic expressions, binomial expressions, the first term multiplies the entire bracket, and the second term multiplies the entire bracket. When we consider that, that means we have 2 root 3, that's the first term, multiplies everything here, root 5 minus 3. And then we are done with 2 root 3. We proceed to the next term, plus 1, multiplies everything here, root 5 minus 3. What we've done is that the first term multiplies the entire bracket, the second term multiplies the entire bracket. So we can open up this bracket and simplify. When we open up 2 root 3 times root 5, when you want to multiply this kind of expressions, the number multiplies the number, the surd multiplies the surd. So the number here is 1, that's the coefficient. 2 times 1 will give me 2. Root 3 times root 5 will give me root 15. 3 times 5 is 15. I'm done with this. Then 2 root 3 times this, I have minus sign. This is a number, so 2 will multiply the number. 2 times 3 is 6. This is a surd, no surd here, so root 3 remains root 3. Then plus 1 will multiply it. Of course, we know 1 as the identity of multiplication. So when 1 multiplies anything, they remains the same. So 1 times root 5 will give me root 5 minus 1 times 3 will give me 3. So I have this. Subtraction, addition, subtraction. Remember in the previous class, I said before you add or subtract anything, they must look similar, they must be the same. So this is a surd, this is a surd, this is a surd, this is a number. Look at the surds, are they similar surds? It ended with root 15, ended with root 3. They didn't end with the same surd. They are not similar, we cannot subtract them. Root 5, root 3, not similar, we can't add them. Root 5, root 15, not similar, we can't add. This is a number, we can't add or subtract a number from a surd. So these things cannot be subtracted, they cannot be added because they're all different. So we can't proceed further. This becomes the final answer. As easy as that. So we end here. It cannot be simplified further. So we look at the second problem. The second problem. I want you to look at these problems very well. Do you notice any difference between these two numbers? This is quite noticeable that they are quite different, but this, when you look at them very well, you should notice that the only difference there is that one is plus, the other one is minus. So when we have this kind of surds together, they are called conjugate surds. When surds are almost the same, but the difference between them is that one is plus, one is minus. They are conjugate. So this is a conjugate surd of this, and conversely, this is also a conjugate surd of this. Look at this, the one we've done previously. When we multiply this and multiply this, we got an answer which is also a surd. But when we do this, I bet you and I guarantee you at the end of this solution, we are not going to have any surd. We're going to have a rational number. A rational number. That is when you multiply two conjugate surds because they are conjugate. I have two ways we can do this. The first one, I will use the method I used here. So this 3 root 2 multiplies everything here. 3 root 2 minus 1. The next term is plus 1, multiplies everything. 3 root 2 minus 1. So we simplify. 3 root 2 times 3 root 2. Remember what I said before, the number multiplies the number, the surd multiplies the surd. 3 times 3, 9. Root 2 times root 2, that's 2. Because root 2 times root 2 gives you root 4. And square root of 4 is 2. So 9 and 2 is 18. This gives me 18 minus 1 times this is still 3 root 2. And then plus 1 times this, 3 root 2, plus and minus, minus. 1 times 1, 1. So look at this very well. They are similar surds, so we can add or subtract. So when you add and subtract, what do you have? Minus 3 root 2 plus 3 root 2, they are similar, they are the same. But one is minus, one is plus, so they cancel themselves out. Just like when you are owing this value and you added this value to it, they cancel themselves out. So we are left with 18 minus 1, and this is 17. Like I said before, these are conjugate sorts, and anytime you multiply two conjugate sorts together, your answer will not be a sort. Your answer will be a rational number. As simple as that. But I will show you an easier way we can do the second question without having to expand. Because by eyeball test, we can see that they are the same thing, except that one is plus, one is minus. Just like in algebraic expressions, if I have a plus b, a minus b, these and these are of the same form. The difference is that one is plus, one is minus. I can expand this, I can open up this bracket. A times a will give me a squared minus a times b, ab, plus this times is ab, and then plus minus b times is b squared. Like I explained here, this we cancel this, and you're left with a squared minus b squared. This should sound familiar. The square of one quantity minus the square of another quantity. In mathematics, we call it difference of two squares. Difference of two squares. That means whenever we have an expression multiplying exact expression except the interchange of the signs, we can apply difference of two squares to solve it. That is the square of the first one minus the square of the second one. So since we can apply this knowledge, I can be able to solve this without expanding. So I have 3 root 2 plus 1, 3 root 2 minus 1. If I apply my difference of two squares without having to expand, I will just pick the first quantity, 3 root 2, and I will square it. And then minus. Pick the second quantity, 1, and I will square it. Difference of two squared. I didn't have to start expanding. So I square this now. 3 squared is 9. 9 dot means times. Root 2 square, of course, square can cancel out square root. We are left with 2. So 9.2 minus. This is not 92, please take note. 9.2 means 9 times 2. 1 square is 1. So what is 9 times 2? 18 minus 1. What is 18 minus 1? 17. The same result we got here. So we can multiply two conjugate sorts together by either expansion or by either application of difference of two squares. Thank you. I will give you what to do quickly. Quickly, drop your answer in the comment section. Let me know how many of you got the lesson. If you have any question, please, you can drop it for me. So you solve this 2 minus 3 root 2, and then 2 plus 3 root 2. You can easily apply your difference of two squares there because they are conjugates. Or you can easily expand any of the two methods